Hello, a warm welcome to RK Academy. Today we are going to learn the physics. As all of you know that physics plays an important role in the field of competitive examinations like Navy, SSR, AA and several competitive examinations. Here, to make the people to learn physics more easily, that do not feel difficult, we are going to give a brief explanation on each and every topic, and today we are going on the topic of waves. Well, wave, it's the most familiar concept to everybody who can see this kind of waves in water, and even when you are studying that sound propagates in the form of wave, even light also propagates in the form of wave. Not only that, even today whatever the TV and radio broadcastings that we are getting, that also comes through the space in the form of radio waves. So, the concept wave is an important and very familiar and very interesting topic. But first of all, let us know that what is wave. The definition of wave is given that a wave is a disturbance created in the medium and is transferred from particle to particle, particle to particle and so on. That in the sense, imagine that you have gone to an undisturbed surface of water. See, let us imagine that this is an undisturbed surface of water. Okay, then if a stone is dropped at a point, if a stone is dropped at a point, then it causes a disturbance. It causes a disturbance, and the disturbance is carried. See, if a stone is dropped at this point, here it causes the disturbance on the particles of the water. Then the particle starts vibrating, and the vibration carried to the next particle and carried to the next particle and carried to the next particle and so on. Thereby, you will observe some kind of ripples forms on that undisturbed surface of water. Then if you see that this disturbance is carried from particle to particle and so on, thereby a wave is formed. A wave is formed. So that is why wave is nothing but a disturbance created in the medium. A disturbance created in the medium and which is propagated and which is transferred from particle to particle and so on. Now, let us come to know the types of waves. See, generally we have two kinds of waves, mechanical waves and non-mechanical waves. Non-mechanical waves by itself, it is known to be electromagnetic waves. Coming to the mechanical waves, what are mechanical waves? See, mechanical wave means generally the wave which needs a material medium for the propagation of the wave. The wave which needs a material medium for its propagation, that is known to be mechanical waves. Means mechanical waves can only propagate when the medium is there. Material medium means it might be air, it might be water, it might be some other. And these mechanical waves are again two types, that is progressive wave and stationary wave. Then what are progressive waves? Progressive wave, progress means moving forward. Moving forward in the sense, the wave which is originated at a point and moves in the medium in forward direction. That in the sense the wave never come back, it always moves forward. For example, if this is the point where the wave is originated and this wave moves only in forward direction, it never comes back, then such kind of wave is known to be, this is progressive wave. Progressive wave never come back. And the progressive waves are furtherly classified into two types. Progressive waves are furtherly classified into two types. One is transverse wave, the other one is longitudinal wave. Then transverse wave. Transverse wave in the sense the particles of the medium vibrates perpendicularly to the propagation of wave. That in the sense, if a wave is propagated in this direction, the particles of the medium vibrates perpendicular to it, perpendicular to the direction of propagation of wave, perpendicular in the sense making 90 degrees. Then the wave is carried out like this. Then whatever the wave is formed, that is known to be transverse wave. So transverse wave can be defined as the wave in which the particles of the medium vibrates perpendicular to the propagation of wave, then the wave is said to be transverse wave. Here if you have seen, this portion is known to be crest and this is known to be trough. Here in transverse wave, crests and troughs are formed. See, this is crest and this is trough. Crests and troughs are formed. And here this is the amplitude of the wave. This is the, say, this is the direction of propagation of wave and this is the mean position where the particles are vibrating. Means here particles vibrates from this mean position. So from the mean position, at what height the particles vibrates, this is known to be amplitude. This is known to be amplitude of wave. Amplitude of wave. So transverse wave generally are which can form crests and troughs. Which can form crests and troughs. And let's come to this transverse wave again when you are learning about the wavelength and characteristic properties of wave. So this is about transverse wave. And the next one is that longitudinal wave. This longitudinal wave in the sense, see for example, if you have taken a spring and when you are making the spring pushing towards and close to each other and pushing and pulling out, when you make a frequent pushes and pulls, then you can observe the spring will come in this direction. The spring will comes to this. See, if you see that some spirals are very close to each other. Here some spirals are very close to each other and some spirals are very distant to each other. Some spirals are very distant to each other. This is the because of when you concern this to the medium, particles of the medium, here when the disturbance is created, the particles vibrates, those particles vibrates along with the direction of, if this is the direction of propagation of wave and the particles also vibrates along the direction of propagation of wave, then whatever the wave is formed, that is known to be longitudinal wave. That is known to be longitudinal wave. Here whatever the spirals that you observe which are close to each other, that in the sense there the particles are vibrates very close to each other. Particles vibrates very close to each other, then that is known to be compression. That is known to be compression. And here whatever the spirals which are distant to each other, here particles vibrates very distant to each other, this is known to be rarefaction. So in longitudinal waves, compressions and rarefactions are formed. In longitudinal wave, compressions and rarefactions are formed. See, for make you a better look, if this is the direction of propagation of wave, if this is the direction of propagation of wave, the particles of the medium vibrates along with the direction of propagation of wave, and particles somewhere they are vibrating very closely to each other, somewhere they are vibrating very distant to each other. So, the region where the particles vibrates close to each other is known to be compression. The region where the particles vibrates distant to each other is known to be rarefaction. Here compressions and rarefactions are formed. Compressions and rarefactions are formed. This is about longitudinal wave. Longitudinal wave. Now let's come to see the characteristic properties of the wave. The characteristic properties of the wave. Here the wave can be characterized by 6 properties: wavelength, frequency, time period, amplitude, height of the wave, velocity of the wave. We will go with individually. The very first one is that the wavelength. Wavelength. Here wavelength, one wave is known to be one cycle. One wave is known to be one cycle. See, for example, if it is in the case of transverse wave, see, one crest and one trough, it is known to be one wave. One crest and one trough. See, the length of this one complete wave is known to be wavelength. The length of one complete wave is known to be wavelength, which is denoted by lambda. This is denoted by lambda. But in the case of transverse wave, as you know that several crests and several troughs are formed. No? Several crests and several troughs are formed. This is crest and this is trough, and this is crest and this is trough. Thereby, the distance between 2 consecutive crests and 2 consecutive troughs is taken as the wavelength and denoted by the letter lambda. Denoted by the letter lambda. And here, when the distance is considered between one crest to one trough, this is half of the wavelength, lambda by 2. Half of the wavelength. For example, in the examinations, it may be asked that the distance between a crest and trough is 10 centimeters. What would be the wavelength of that wave? See, if the distance between crest and trough is 10 centimeter in the sense, the lambda by 2 is given 10 centimeters, then obviously lambda equal to 2 10 20 centimeters. Or if it is given that the distance between 2 consecutive troughs is 15 centimeters. The distance between 2 consecutive troughs means if it is given 15 centimeters, then what about the distance between crest and a trough means you have to do lambda by 2. Lambda by 2 in the sense that will be 7.5. 15 by 2 is equal to 7.5 centimeters. So, in this way we can calculate the wavelength. When it comes to the concern of longitudinal wave, when it comes to the longitudinal wave, then see, let us have a look upon the longitudinal wave. As you know that longitudinal wave where compressions and rarefactions are formed. So, compression is the region where the particles vibrates very closely to each other, and rarefaction means the region where the particles vibrate distantly each other. So, this is one compression and one rarefaction. This is known to be one complete cycle of longitudinal wave. The length of this complete wave is known to be lambda, wavelength. And here, as you know that longitudinal waves means where a series of compressions and rarefactions are formed. No? So, thereby the distance between 2 consecutive compressions, the distance between 2 consecutive compressions and the distance between 2 consecutive rarefactions is known to be wavelength lambda. As I told you, in the case of transverse wave, here also the distance between a compression and the immediate rarefaction, that is lambda by 2, is known to be half of the wavelength, is known to be half of the wavelength. Wavelength, simply to understand, it is the length of a complete wave, which can be given definition in the case of transverse wave is the distance between either two consecutive crests or two consecutive troughs. It can be given a definition in sense of longitudinal wave, that it is the distance between either two consecutive compressions or two consecutive rarefactions. Okay. Now, let us come to know the another characteristic property, that is frequency. Frequency is nothing but, see, number of waves. As I told you that one complete wave means one crest or one trough in sense of transverse wave, one compression and one rarefaction in sense of longitudinal wave. That one complete wave considered to be one cycle, and the frequency can be defined as the number of cycles produced in 1 second. Number of cycles produced in 1 second. Produced in 1 second in the sense, number of, for example, if this is a transverse wave, where in 1 second, see, this much of crests and troughs are formed in the span of 1 second. How many? 1 second. Here, this is one complete wave, this is one complete wave, this is one complete wave. How many cycles are formed? 3 cycles are formed, means 3 waves are formed, 3 complete waves are formed in 1 second. So that frequency can be given a definition or formula as number of waves by time. Number of waves by time. Number of waves means how many waves are formed here 1 second? 3 waves are formed in 1 second. So, thereby 3 by 1 is equal to 3. So, frequency is 3 hertz. Frequency is 3 hertz. So, number of cycles formed or produced in 1 second is known to be, 1 second is known to be, that is frequency. And the next one is time period. Time period in the sense, see, this is a complete wave. The time taken to form one complete wave is known to be time period. To form a complete wave, one complete wave, how much time is required? That is known to be time period. The time required for the formation of one wave is called time period. Time period is always expressed in terms of seconds, hours, minutes, etc. Mostly in seconds. This is the third characteristic property which can be characterized by the waves. And the next one is amplitude. This is the most important thing, amplitude. Amplitude in the sense, see, here this is the direction of propagation of wave. The waves are producing like this. And this is the mean position. See, this is mean position of the wave. The particles vibrates up and down from this mean position. So, here the particle vibrated up to here from mean position. Here also the particle vibrated up to here from the mean position. And this is also the length or the vibration of the particles or the extent of vibration of particles from the mean position. That is known to be amplitude. Amplitude is nothing but the extent of vibration of particle from the mean position that is known to be amplitude. And here, so this is the lower limit and this is the upper limit. The distance between the lower limit or lower boundary to upper boundary or upper limit, this is known to be height of the wave. Height of the wave. Generally, amplitude will be half to the height of the wave. Amplitude is generally half to the height of the wave. This is about amplitude, the fourth characteristic property. The next one, we are going with the velocity of wave. Velocity means the wave will propagate. No, the wave propagates at a certain velocity. Then the velocity of wave can be given as the distance travelled by the time. Distance travelled by the time. Here distance is nothing but wavelength. The distance what you considered is nothing but wavelength by time. So generally V is given lambda by T. The relation between the wavelength and frequency, lambda is equals to 1 by lambda is equals to frequency. Sorry, the distance, the relation between frequency and time, f is equal to 1 by t, or f also it can be written as nu, so that it can be written lambda into 1 by t, that is equals to V is equals to nu lambda. V is equals to nu lambda, where V is the velocity of wave, nu is the frequency of the wave, where lambda is the wavelength of wave. So here a wave which is propagating with a frequency of 3 Hz and the wavelength is given 10 centimeters. What is the velocity of wave? Here the frequency is given 3 Hz and wavelength is given 10 centimeters, then V is equal to nu lambda, that equals to 3 into 10, 30 meters per second, 30 centimeters per second. So this is the way to calculate the velocity of wave with this. Okay. So we have learnt the characteristic properties. The very first one is wavelength, second one is frequency, third one is time period, and fourth one is amplitude, and fifth one is height of the wave, and the sixth one is velocity of the wave. So this is about the progressive wave, and the next one is stationary wave. Here stationary wave, to understand the stationary wave, here we have to go with a small thing. Here let us imagine two progressive waves. As I told you that progressive wave means which propagates only in forward direction. See, this is one wave which is propagating in this direction. It is propagating in this direction. This is the second wave which is propagating in this direction. This is first wave and this is second wave. These two waves are of equal amplitude and equal frequency. Both the waves are of same amplitude and same frequency. Those two are moving along a same path. This is the first wave is propagating like this, and this is the second wave which is propagating in the opposite direction. It is opposite direction, and these two are moving on the same path but in opposite direction, and they are superimposed by each other, and whatever the wave is formed, that is known to be stationary wave. Here stationary wave, the definition is given that when two waves of equal amplitude and same frequency are moving along the same path but in opposite direction and are superimposed by each other, and the wave formed is known to be stationary wave. Here, as the stationary wave is formed, here two things are very important. As those two are superimposed by each other, this is the position where the minimum displacement of the particles can be observed. See, this is the position where the minimum displacement, the region where the minimum displacement of the particle is observed, that is known to be node. Nodes are formed. Generally, node is a region where the particle can undergo minimum displacement, and here this is the region where the particle can undergo maximum displacements, and such regions are known to be antinodes. AN means antinode. AN means antinode. In stationary wave, nodes and antinodes are formed. The distance between two consecutive antinodes or two consecutive nodes is lambda by 2, half of the wavelength, and the distance between a node and an antinode is lambda by 4, 1/4 of the wavelength. Here you see, here, so you see this is antinode and this is node. This is antinode and this is node. This is antinode. The distance between two nodes is lambda by 2, and the distance between two antinodes, that also lambda by 2. The distance between a node and antinode, this is lambda by 4, 1/4 of the wavelength. This is the stationary wave. And we have learnt till here about mechanical waves. Mechanical waves means for the propagation of wave, the material medium is required. All these waves can propagate in medium only. Without medium, these waves cannot propagate. But when it comes to the electromagnetic wave, this electromagnetic wave, which is and which can propagate in vacuum in the sense where there is no medium. Electromagnetic waves can propagate in medium as well as in vacuum. Now let us come to see that what is the speciality of the electromagnetic wave. Generally, as we are discussing about the mechanical wave, we always learnt about that the wave which is formed, that is a disturbance in the medium and which creates disturbance to the particles, thereby particles are vibrating. Here no particle physically vibrates when the electromagnetic wave is formed. Then how the wave is formed? Means here the charge, generally charge vibrates. Yes, charge, which is having either positive or negative charge, which vibrates. The charge, as it is vibrating, it creates an oscillating electric field. The vibration or oscillating of charge which creates oscillating electric field. Yes, the electric field is oscillating. Due to the change in electric field, the magnetic field will be formed. So here two fields are formed, electric field is formed and magnetic field is formed, and these two fields also vibrates or oscillates. And how they oscillates means electric field oscillates perpendicular to the magnetic field. Electric field is oscillates perpendicular to the magnetic field, and both oscillates perpendicular to the direction of propagation of wave. So when the wave is formed by oscillating electric field and oscillating magnetic field, which are oscillating perpendicular to each other, and are also oscillating perpendicular to the direction of propagation of wave, then the wave is said to be electromagnetic wave. Electromagnetic waves can also propagate in vacuum. So medium is not necessary for the electromagnetic waves, and these electromagnetic waves are also known to be non-mechanical waves. Non-mechanical waves. So mechanical means medium is required, non-mechanical means where the medium is not required. So electromagnetic waves are so many, in the sense, for example, see, have you ever seen the spectrum? Spectrum in the sense here, if you have taken a prism, and in that prism when you pass a light ray, then if this is a prism, and here when you pass a white light ray, the white light ray splits into 7 different colors, This is violet, indigo, blue, green, yellow, orange, red. So all these united together, the group of all these colors is known to be electromagnetic spectrum, where our eye is sensible towards these, means we can see these colors. So that this spectrum is known to be visible spectrum. This spectrum is known to be visible spectrum. So the visible spectrum is a part of electromagnetic wave, and apart from this visible spectrum, there are so many waves are there, electromagnetic waves are there. See, we have ultraviolet radiations, we have radio waves, we have infrared radiations, we have gamma rays, X-rays, cosmic rays, all these are known to be electromagnetic waves. And electromagnetic waves can go with a speed, velocity with 3 into 10 to the power of 8 meters per second. The velocity of electromagnetic wave is 3 into 10 to the power of 8 meters per second. And here in visible spectrum, we have 7 colors, I told you: violet, indigo, blue, green, yellow, orange, red. Here the wavelength, red is of longer wavelength, violet is of shorter wavelength. Red is of longer wavelength, that is why the red color is used for dangerous symbols. And the frequency for violet it is high, and for red it is low. And let us see the frequencies and wavelength of this gamma rays. Okay, Yeah, see, gamma rays are 10 to the power of 20 to 10 to the power of 24 hertz, and the wavelength range is less than 10 to the power of minus 12 meters. Ultraviolet rays, the frequency range is 10 to the power of 15 to 10 to the power of 17 hertz, and the wavelength range is 400 nanometers to 1 nanometer. X-rays, 10 to the power of 17 to 10 to the power of 20 hertz frequency range, and 1 nanometer to 1 picometer, that is the wavelength range of X-rays. And visible spectrum is 4 to 7.5 into 10 to the power of 14 hertz, the frequency range, and the wavelength range is 750 nanometer to 400 nanometer. And the nearby infrared radiations are having a frequency range 1 into 10 to the power of 14 to 4 into 10 to the power of 14 hertz, and the wavelength range is 2.5 micrometer to 750 nanometer. Infrared radiations are having the frequency range 10 to the power of 13 to 10 to the power of 14 hertz, and the wavelength range is 25 micrometer to 2.5 micrometer. Microwaves means the 3 into 10 to the power of 11 to 10 to the power of 13 hertz, and the wavelength range is 1 millimeter to 25 micrometer. Radio waves, the frequency range is less than 3 into 10 to the power of 11 hertz, and the wavelength is very long, that in the sense more than 1 millimeter up to 100 kilometers. And all these electromagnetic waves are having their own advantages. See, gamma rays are very intensified, and which is mostly used in medicine to purify or to kill the cancer cells. Gamma rays are such powerful rays which can even penetrate deeply into the hardest material, and they can kill the cells. That is why it is used in the treatment of cancer. X-rays, as you know, X-rays are two kinds, soft X-rays and hard X-rays, and X-rays generally are used to take a photograph of the fractured bones in medical field, and it is also used to see the internal flaws of the metals, heavy metals. And when it comes to ultraviolet radiations, UV rays are very important, as you know that it plays a prominent role in the atmospheric field. And visible spectrum, as we can see these colors, visible spectrum. Infrared radiations are very useful to take photographs in darkness. See, infrared rays are very useful in the photography industry. Microwaves, these are very useful in microwave ovens and telecommunications and even satellite communications. Radio waves are very useful to the propagation of the TV transmissions and radio transmissions in the form of radio signals. Radio waves which can broadcast by modulating with them. So, electromagnetic waves which plays a prominent role in the field of science, in the field of medical and the field of atmosphere and everything. So, this is the total description of waves. And once if you recall the wave is a disturbance created in the medium and passing from particle to particle. Here you have to understand one thing very clearly, that the waves generally requires the two things very clearly. One is elasticity and other is inertia. Elasticity means, you see, if you take a rubber band, when you stretch it up, what happens? The rubber band will expand. When you leave it again, it regains to its own position. Regaining of its own position is known to be elasticity, where inertia is nothing but keep on moving, keep on in the remaining into the same state. See here, for example, if a disturbance is created in the medium, if this is a medium where the disturbance is created, here the particles vibrates, this vibration is carried to the next particle. So, the vibration is transferred to the next particle, the first particle will regain its own position, and the particle vibration is transferred to the third one. second one will regain its own position. After transferring to fourth particle, third one will regain its own position. So regaining own position is nothing but elasticity. So that elasticity is the main property for the formation of waves, and this transferring will carried out throughout the wave. So it's keep on transferring means inertia of transfer. So that inertia is another property which is required for the propagation of wave. So the two requirements for the propagation of wave is, one is elasticity, the other is inertia. And we learn the types of waves, that these are generally two types, mechanical and non-mechanical. Non-mechanical are known to be electromagnetic waves. And again, mechanical waves are two types, progressive and stationary. And progressive waves are furtherly two types, transverse and longitudinal. And we have learned the characteristics of the properties, the wavelength, frequency, time period, amplitude, height of the wave, and velocity of the wave. And we have gone with electromagnetic wave, that is the non-mechanical wave, and also stationary wave we have gone with. The next one is electromagnetic wave, and we have gone with the different electromagnetic waves and wavelengths and frequencies. Thank you.